Hello. Hey everyone, this is Keegan. Uh, hey everyone, this is Keegan. And today we are going to be talking about probability, one of my favorite math subjects, but one that is not very well understood, and I know it causes a lot of problems for students at the primary junior level. So hopefully we'll get it all straightened out today. So we're using one of my favorite sites today, random.org. You can see here. It's a random number generator, and there's dice, there's coins, there's a lot of different cool things we can do with that site to do these kind of probability experiments. So we're using two normal dice today, and we're going to be rolling them and then tracking our progress. So first off, never mind what these dice actually say right now. Here we have our chart. We're going to track what numbers we roll between 2 and 12 and how many times we roll them. So first off, you should make a guess. That's always a good way to start. Let's guess what number is going to be rolled the most out of these two dice. We're going to add them, of course. So I like the number 5. So I'm going to guess 5. Let's highlight 5. And we'll see how many times 5 is rolled. And so the game is the first number that gets rolled 10 times here wins. Okay? So let's roll. So roll again. Here we go. That is an 8. So we'll check 1 for 8. There we go. Let's roll again. 9. There's 1 for 9. 7. There's a 7. 6. 6. Another 6 there. Oh wow, 6 is coming up. So we're going to keep doing this until one of these numbers hits. Maybe we'll say 8 actually, because 10 might be too long. Maybe for a whole lesson we could do 10. This is a short video. The 9 here. So as we continue to roll these die, we should start to realize some kind of pattern, because we know, or hey everyone, this is Keegan, and today we are looking at probability and rolling dice. Here I have a dice tracker set up. We're going to track what we roll. And here I have a random number generating site called random.org. Great site. There's two dice here. We're going to randomly roll them. and see what comes up. So we'll add the two together. So they are numbered 1 to 6, like a normal dice, like in Monopoly or Yahtzee or any of those fun games. So first, I think it's always a good idea to make a guess. So let's guess what number will be rolled the most. So we're going to play a game where we roll the dice, add the total up. Do it now. Hey everyone, this is Keegan, and today we are looking at probability with dice. Now, probability is a bit of a tricky subject. It's one of my personal favorites, but I know it gives a lot of students trouble. And so today, hopefully, we'll iron some of that out and set you up with a really good base for probability. So here we have a dice generator. So this will roll dice for us, just like in Monopoly or Yahtzee. They're normal dice, 1 to 6 are the numbers on them. And on the left side here, we have our chart. So this will track the dice numbers that we roll, the totals, and how many times we roll them. And so the game is, we're going to see what number we roll the most. So we'll see who gets to 5 first, which number. So you can play this a bunch of ways. We're just going to track it today, but if I was really playing with you, maybe I would guess a number. So I would guess 5 is going to be rolled the most, and you would guess 10, and then we would see whose number gets rolled the most, or who hits 5 rolls first. So today we're just going to look at the results. So we'll roll this dice. Here we go. 8. 8 is rolled, so we'll mark 8 with a green thing here. Let's roll again. 7. 7. So as we'll see later, the longer we do this experiment, the better. This is a short video, so we're only going to go up to 5. But the longer you do it, the more accurate results you'll get. 9. After a while, we should start to see kind of a pattern. 7's going strong here. 9 again. So I call it a pattern, but the whole point of this is that it is probability, which means that even though there are rules and there are general trends, it doesn't necessarily mean that it's going to work out the same every time, because there's some amount of chance in this. Hopefully with this experiment, oh, and look at that, 8 wins. So as you can see here, or maybe you make an observation. What do we see? So where are the most dice rolls? So we see there's a lot towards the middle here. You see? 6, 7, 8, 9, all really strong results. While on the outside, so 2 and 12, there's not a lot. So that would be it for about a grade 3 level. We would just see that not all numbers are equal. That's the message. If we want to go a bit more advanced to maybe a grade 4 or 5 level, we would start thinking, well, why? Why are 6, 7, 8 rolled more than 12 or 2? So we would bring up a chart like this. How many ways can you make, and then you have the numbers here. So this is with 2 dice. How many ways can you make 1, for example? Obviously that's impossible, because no matter how many times you roll it, you can't get 1, because the lowest you can roll is a 1 and a 1, which would be 2. So leading to how many ways can you make 2? How many possible different combinations can you make? There's only one combination, a 1 on this dice and a 1 on this dice. Now, how about 3? Well, that you can do a 1 and a 2, or this being a 2 and this being a 1. So it's 2 combinations. And then you see that it starts to be a pattern. Okay, so 1 plus 3, 2 plus 2, or 3 plus 1. So that's 3 combinations. As you can see by the shape of this chart, the more combinations you have, the longer this gets. So, what number has the most combinations? Looks like 7, judging by the width of this. So you could make 7 by rolling a 1 plus 6, a 2 plus 5, a 3 plus 4, a 4 plus 3, a 5 plus 2, or a 6 plus 1. So now we can kind of see why 6, 7, 8 is rolled way more up here than a 2, or a 12. Because if you roll a die like this, 6 plus 6 is 12, 3 plus 4, 3 plus 1 is 4. There are 3 different combinations of making this. So it is much, much, much more common, or easy. It's easier to roll a 7 than a 2 because there are so many ways to make a 7 and only one way to make a 2. So next we'll move into practical applications. So why is this important? Because that's nice, and we have this chart, and we have this tracker. But why does it really matter? Well, there are many, many applications. Think about if you're starting, or if you're playing Monopoly, and you have the option of putting a property on a space that's 7 away from the start, or 10 away, or 9 away from the start, let's say. So which would be the better property? Where are people more likely to land on if they're going from start? So if they're starting from start and they roll 2 die, they have a really good chance of rolling a 7, right? 6 plus 1, 2 plus 5, 3 plus 4. Not a great chance of rolling 9, 3 plus 6, 4 plus 5. So hopefully you'll have more people landing on 7 than 9. So you should pick the 7 spot. That's just one example of the many ways that probability is important to a young person like yourself. This has been Probability with Dice. Thanks for listening, and hope to see you again soon.